Hi all, this is Vishal Singhal from Sep'19. I'm AI evangelist and co-founder with the company. Today we have an important topic on image manipulation detection being delivered by Ms. Sonal Kukreja. She is PhD research scholar and computer vision enthusiast, as well as founder of 10x10io.io from Thapar University in Patiala. So I some logistics comments here. So we will be having this webinar for about an hour or so. I encourage you to keep putting questions as and when they come to your mind. But until it is critical on the slide that you are asking for, we will try to answer these towards the end of the webinar. We are recording this webinar, so the recording will be available on our Self-Stat YouTube channel in about 3 to 4 days time. Uh, until then, be patient. Have full try to get full value out of this. Ask as many questions as possible. She has a very good knowledge. And over to you, Sonal now.
Okay, thank you, Vishal. I would just a second start my. Okay. Is my screen visible?
Yeah, go ahead.
Okay, so I'm going to speak about image manipulation detection. So I will introduce myself also briefly. So before that, I would show a picture. We can see a picture here. We can see that there are many people standing, but all of them have the same face if we have just have a look carefully. So this is a tampered image, or we can say this is a manipulated image where the image has been edited and every person has been replaced, like a face of every person is being replaced by one person. So with the like these, this was one of the examples. I would be showing many examples along with the presentation. So I'm Sonal Kukreja and I'm here to talk about image manipulation detection techniques. So we know that with the advent of social networking services like Facebook, Instagram, there has been a huge increase in the volume of image data which has been generated in last few decades. And also availability of image processing softwares like Photoshop. The image can be easily doctored, like they can be easily manipulated. Even the videos can be easily manipulated and shared, and they just get viral so soon, and they are a source of fake images these days, like fake news these days. So these images, they are prime sources of fake news, and they're often used in malevolent ways, such as for mob incitement. They just get viral. Any picture is replaced by anything, they gets viral. Like we can see one more image in front of us. Actually, it's a aircraft standing aircraft on the ground, but just the background of the image was manipulated, and the picture got viral few months back. So in this way, we are there exist many techniques to handle with such kind of images. So first of all, like what are the different algorithms which we used for this image forgery? This image tampered, like manipulating the images is also termed as image forgery. So what all these are the algorithms which exist on Photoshop. Like one is content aware fill. Just a second. Okay. Yeah. So one of the algorithms is content aware fill and patch match. This technique exists on the Photoshop. It is just for copying pasting, that we copy an object from one image and paste it on different image. Then we have content aware healing for copy pasting and splicing. This is also a similar algorithm. This is also a similar technique which exists in Photoshop, but it is designed like just to select a particular area and paste it on a different image just to improve the quality of that image. Another is clone stamp for copying pasting. Clone stamp is that we are creating, like suppose there is a picture, there is a person standing on that picture, and we create a clone of that person and paste it on the same image. So here the two images, like in the above two algorithms, two images are involved, while in the case of the third one, we are cropping the object from the same image and pasting on and creating a clone within the same image. Then we have scene carving. This is content aware image resizing. That is, we do not copy or paste anything. We just resize the image. Like if we have a smaller image, we increase the size and every object gets magnified. Then we have in painting. In the case of in painting, it is the reconstruction of the damaged part. If any of the part has been damaged, so with the help of copy and paste, we can just paste some copy a patch from within the same image and paste it there. So we can modify the image in that way. Then one technique is alpha matting, which is also known as, like, it is basically used for splicing. What do we do in alpha matting? That is, we extract the foreground and the background of the image specifically for targeted on the foreground from the image. Like we would separate the foreground and the background, and then we can replace it with some other image. So these are some of the algorithms which exist in Photoshop. Using these, the images are tampered, and when we share the tampered image, we have to focus on these algorithms to detect which image is original and which image is fake. So just a minute, yeah. So before we move ahead, we would discuss some terminologies which are used in the case of image tamperedness. So one is fake image, one is pristine image, and the third one is image splicing. So what's a fake image? Fake image is like an image that has been manipulated using the two most common manipulation operations, namely copy paste or splicing. So copy paste means copy from other image and paste it there, and splicing means extracting the part and paste in there. Then we have a pristine image that has not been manipulated, just except for the resizing needed to bring all the image to a standard size or for any other purpose. So here we do not manipulate it, we just resize it. Then again, I would use that same term, image splicing. So splicing operations can combine images of people, uh, like we have some people there, adding doors to the buildings, adding trees and cars to the parking lot. So it's basically we have one image and we are adding some more objects to that image. So the spliced images can also contain resulting parts from copy pasting operations. So the image receiving a spliced part is known as host image, and the parts which are being added are called as aliens. So these are some common terminologies which we use in the case of when we talk about image manipulation techniques. Like this is one of the most common pictures which is uh, floated around during our festival Diwali. The actual image is the satellite image which is taken, but just by increasing the brightness, adding the light effects on certain images, the image is manipulated, and which we can see on the left hand side. This is an example of image splicing. We can see that on the first image, we have a picture of a monument. Then the second image is of a girl, but the background of the second image has been replaced by the first one. So this is an example of image splicing. Okay. This is again an example of image splicing. We have an image on which, like, the right one, like we can take anyone as the original or the manipulated. We can see that person on the chair is not existent on one image, but it was copied and pasted on the second image. Or we can take, like, he was present, but it has been removed. So in any case, it is an example of edited image. So first of all, we would classify, like, how there exists a lot of research is being done on this particular area for last few decades. So there are two types of techniques actually. One is active approach and one is passive approach. In the active approach, there are two sort of examples. One is watermarking and digital signatures, while in the passive approach, we have independent and dependent techniques. So first of all, what is the difference between active approach and passive approach? What happens in the active approach, like active approach was being worked upon and being used uh, in the case of like when you are the when suppose one of us is the owner of the image, or there is some photographer, he has an album of images, he's sharing on, he has a website, he's sharing his images, and he want to protect his own images so that no one else can copy and modify and share it by his name. So he adds a digital watermark or a digital signature to it to protect that particular image. So those techniques are known as active approach, in which we have a sample of images, we have a data set of images which we need to protect, and we usually protect it with the help of a watermark or a digital signature. While in the case of passive approach, there is no particular owner or there is no particular data set which the owner owns. It's generalized images which are being shared on social media or on the web. And just by looking at those image and uh, working on them, we need to detect whether that image is original or tampered. So presently, like both of the techniques have been, they have different applications. So the first technique has applications in which we need to protect one image, and in the passive approach, we do not have particular target. We just need to detect whether the images are being shared are original or fake. So first, I would just discuss a little bit about the active approach, in which I would discuss the watermarking, and then we will come to the passive approach. So what happens in the active approach is that suppose you have an image, we have this image, the host image. We use some technique, any sort of techniques, many techniques are existing on digital watermarking. So we use different techniques. We have a watermark. So I think this arrow should be reversed. The watermark and the host image are both being provided as input to the embedding algorithm, and we get a marked image. So this image which we can see here, uh, which I have been marked as marked image, which I have labeled as marked image, consists of the watermark also. The watermark is hidden in this marked image in such a way that just by looking at the image with the naked eyes, it should not be visible whether the image is or whether the watermark has been hidden inside it. Then the marked image is stored on internet or transferred through any insecure channel. And if later we need to verify whether the marked image is like whether the image has been tampered or whether the image has been owned by someone else, we extract the algorithm. We perform an extraction algorithm. We extract the watermark. If we are able to extract the watermark as it is, like as it was in the original form, we can say that the image is still our own image. We have the copyright on the image, or the image has not been modified. So this is like I can show, like there was one of the papers. Just a minute. So this was one of the papers which I had worked like 2 years back. So it's just a sort of example I'm giving how the watermarking approach works. So suppose this is an image block. Okay, so these are the image pixels, although the image is usually of 512 cross 512 size, or it's of larger size. I've just taken some sample pixels. So pixels, like if it's a grayscale image, the pixel values usually lies between 0 to 255. So this is a small block of image. We performed some calculations on it. Like I would go that much into detail because this was the complete proposed algorithm. So we did some manipulations onto it, and we embedded the watermark, and we received this image, like this plot. So if we have a look, let's have a look on it. Just a second. Okay. Yeah. So we see in the original image, the first pixel was 163, 156, 164, and 160. Because we have embedded the watermark inside it, so it has been modified to 162, 156, 163, and 160. So we can see two pixels have been modified, the first pixel and the third pixel. So in similar way, the rest of the pixels, like some of the pixels are modified, but they are so, like this change is so minor that it is not visible to the naked eyes. So this is an example like how we embed the data. In the case of watermarking techniques, we embed the data inside the image. Sorry. Yeah. So the main disadvantage of this watermarking techniques was that the watermark is being hidden inside the original image. So the quality, like although the changes are not that what like the changes are not visible to the human eye, still we are hampering the quality of the image because we are modifying the actual pixels of the image. So there is a small modification to the watermarking techniques, which was visual cryptography. Now what happens in the visual cryptography, it is also sort of watermarking technique. In the case of, like, first of all, I would discuss the visual cryptography. What is visual cryptography? Suppose we have an original image, although it's an example of a cryptography technique in which we need to encrypt the data and share between different users. So in the case of visual cryptography, we actually do not encrypt the data, but we have an image, we divide the image into two shares. We divide the image into two some random looking shares, like what you can see, the share 1 and the share 2. Now at the time of extraction, first of all, we do, like at the time of decryption, I'm sorry, at the time of decryption, you do not have to perform any decryption technique, but you have to just overlap those two shares and the image is retrieved back. Like we can see when the share 1 and the share 2 are being overlapped with each other, we can see Wikipedia written. So the original image was Wikipedia. We created two shares from it, two random looking shares. Just by looking at those random looking shares, no one can detect what information is being shared. And when you overlap them, the original image is retrieved back. So the main advantage of this technique was that no complex decryption algorithm has to be performed. The decryption, like this particular cryptography, is used only in those cases when we do not need any complex decryption algorithm. So this has some of the applications in cloud computations and so on, in which we need to share a secret among different users, and it can be retrieved back only when all of the users come together and overlap their shared images with each other. Like here, I've just shown an example of two shares. It can be possible like with any number of participants. This technique was basically designed on the concept, like suppose some two or three, like suppose two people have a common locker in a bank, and that particular, they have a mutual account and they can access that locker only when both of them put their keys inside it and both of them have their consent, only then the locker can be used. So secret sharing technique was designed on this principle that the secret is being shared among a number of participants, and it can be decrypted only when all of the participants involved have the consent to extract it. So now this technique, the visual cryptography, was used along with the watermarking, because in the case of watermarking, the main disadvantage was that the pixels of the image were being modified. So we just use the visual cryptography along with the watermarking to create a digital watermarking technique. So suppose we have a host image. Okay, this was an original host image. Like I would just share it beforehand, that the cloud and the three birds, which we can see the image, this I had added using the paints. So these are not the part of the original image, but I have modified the original image. So from the host image, we extract some features. Those features are the important features which are necessary, like from which we can construct back the original image, and we just exclude the features which are not required, but they are just handling the brightness and other stuff. So we extract the important features from the matrix. Now these features are extracted, either applied using different transforms, or we have various sub features or SIFT features. So any kind of, like, I'm just giving a brief introduction, that is, we just extract some features, important features, which are representing the important objects in the image. From that features, after applying some mathematical computations, we create a master share. So what is a master share? Master share is a binary data. It would be acting as the share one, which we discussed in visual cryptography, and it contains all the information about the host image because it has been created from the feature matrix. Now, using the master share and the watermark, we create another image which is known as ownership share, which is stored with the owner or some trusting authority, and then this host image is shared on the insecure channel. So now we have not embedded the watermark inside the original host image, but we have just combined it with the master share, created one more key. We can call this ownership share as a key, which is stored with the owner. Later, when just a minute. Later, again, from the insecure channel, someone receives the host image. Again, the same technique is applied. That is, when it is provided into the model, when the host image is provided as an input to the model which we have developed, we create again a feature matrix. From the feature matrix, we again create a master share, and now we overlap that master share with the key share or the ownership share that was stored with the owner, and we are able to extract back the watermark. Now on the watermark, you can see the cloud and the three birds have been labeled. So the watermark is not received the way it was originally. The original watermark is not extracted, but the parts which were tampered or which were modified are labeled, like we can see their boundaries, or we can see those gray parts on the image. So this shows that the image which is being shared is not an original image, but some modification has been done. And which areas has been modified, that areas have also been labeled, like that those boundaries are also visible on the extracted watermark. So we call this as localizing those areas. So for one step is that you are detecting whether the image is tampered or not, and second is you are also localizing the areas which have been tampered. So this was an active approach which we had worked on earlier to detect whether the image is tampered or not. But of course, in this case, the owner should have a particular set of images. He should have a watermark, and then we protect that particular image. Then we would have like, these are the tamper detection results. I've shown some of the results. Like, this is the original image in which we had written "smile please," like this. The image was tampered. We had modified the image and stored at "smile please." So when we extracted the watermark, this particular area was gray in region. So we can say that all these pixels have been modified. This is the same previous image which I had shared earlier. The cloud and three birds were additional, which are again being depicted in the watermark. Now we would have a little bit introduction about the image manipulation detection using CNN. So this basically lies under the active approach. So this is something on which I'm presently working on. So we are working on an image manipulation detection algorithm using deep learning. So the model based on CNN, like presently, I will show you just okay. So presently, the technique which we are working on, the algorithm, although the results are not completely, because we are still working on it, but I would just give a brief introduction about how we are moving ahead in this on the image manipulation detection using CNN. So in this, just a second. Yeah. So first of all, we would have a brief overview of deep learning and CNN. A lot of research has been done to solve the problem of artificial neural network. The computation of high complexity has been solved through the development of hardware performance. We have the GPUs and all and we have a large set of data sets also available, and a variety of deep learning models have been proposed. So one of the deep learning models is a convolutional neural network model, which is specialized in image processing. So the convolutional layer includes an input layer, a convolutional operational layer, and a fully connected layer, and then the output layer, which we can see here. This is the overall structure of convolutional layer, or convolutional neural network. So the input layer is the set of input units. It is a passage through which pixels of an image for learning are entered. So we provide the raw image as the input. And what is a raw image? It is a set of pixels which we are provided, which we are providing it in the model for learning. So its size is related to the, like, what is the size of the image? It is the number of pixels. So the size of the input depends on the size of, like, how many pixels are there in that particular image. The convolutional layer, this particular second box, which we can see, the convolutional layer consists of various convolution filters. So across the convolution layer, the result values are passed to the next layer in a non-linearity. In the pooling layer, this we can see, yeah. In the pooling layer, the dimensionality of the data is reduced. And then next, in the fully connected layer, the classification is performed according to the learned results. So multiple fully connected layers can be stacked. Dropout can be applied between each layer to prevent overfitting or underfitting. Finally, the output layer is learned to score each class, and in general, there are many functions which we can use. In general, softmax function is used. So in particular, the convolutional layer consists of various combinations of convolution, pooling, and activation operations. The computation of convolution in a neural network is a product of two-dimensional matrix called an image and a kernel or mask. So that we can see, just a minute. Yeah. So we have an image, we use a kernel, okay? So through this kernel, local features considering the neighboring pixels can be extracted. So just to reduce the size, we mask it with a kernel, and all the local features considering the neighbor features are extracted. Local features considering the neighbor pixels can be extracted. The pooling layer which we were applying after the convolution filter, the pooling layer is to select a pixel value having a certain characteristic among pixels in a specific region. Let's see, um, we have a like, this is a block of image, like we have some values here. When we apply the pooling layer, so the pooling layer, like it, as I said, it just appears after the convolution, and from here it is basically used to reduce the size of that layer. So convolution neural networks generally have a very large number of neurons. So to reduce the complexity of the learning problem, we apply the pooling layer. And pooling layer is like, we can apply maximum pooling or average pooling. So in this particular example, I have shown an example of maximum pooling. So what we have done, we have divided the image into blocks of 4, 4, and from every 4 values, we have selected the maximum value. So in the layer, like, okay. Also, like, after the maximum pooling layer, after we have applied the maximum pooling layer, the brightness is standardized through a layer called LRN, that is local response normalization. Okay, so this would be the flowchart of the technique which we are working on. So we used an input image. Okay, after the input image, we pass it through a high pass filter. So in general, for image classification research, there is a use of image pixel data, and it behaves as it was personally classified. So our research targets those that cannot be distinguished by the human eyes. So we are focusing on that part of the image which cannot be distinguished by the human eyes. So we apply high pass filter, also known as HPF, to extract the hidden features within the image. So I would say, so what do we do? Like, we have an input image, we apply the high pass filter onto that image. So we are able to extract only the high pass filters which are not visible to the human eyes, because we are dealing on that part of the image which are not being visible to the human eyes and which have been tampered. After the high pass filter, we can see, suppose the original image was of 256 cross 256. After applying the high pass filter, we get an image of 252 cross 252. Then we apply different layers of convolutional layers. So in the process of passing through the high pass filter, one channel image of 256 cross 256 is converted into 252 cross 252. So the neuron values of 252 cross 252 pass through a 7 cross 7 kernel of convolutional one layer. This is the convolutional one layer. So this is passing through the kernel of 7 cross 7. Okay. Okay. So initialization, just a second. I would show that. Okay. So yeah. So if we, like, before going into deeper detail, I would just go that, suppose we have a deep learning model, and after that I would come back to the complete flowchart. So what we are doing, we discussed like what is CNN. We have a deep learning model. We have a set of images. From that set of images, we are training that deep learning model. So from those images, with the help of various steps, the learning would be done. And what the learning is done, that whether the image is original or whether the image has been tampered. So when we use the data set, like one case study was that we used a data set, we labeled all the images as fake or original. So the original was labeled by one value and the fake was labeled as one value. We trained the deep learning model from that image data set, and later it was tested, and it returned the result whether it's an original image or a manipulated image. So original image is also termed as the cover image, and the manipulated image is labeled as manipulation. Like, manipulation means it has been altered. So now, how the deep learning, like what are the steps which are being done inside the deep learning model? That has been shown here, that we were talking about. I had started it earlier. Sorry. Yeah. So we had an input image. Just to extract some high pass filter features which are not visible to human eyes, we applied a high pass filter. Then we are passing it to various convolutional layers. This is the first convolutional layer, this is the second convolutional layer, and after that convolutional layer we would be classifying it using the softmax and all. So how we are what is, like, how the convolutional layer is behaving. So we see, like, we got 252. We are sending the 252 cross 252 neurons inside the convolutional layer 1. Initialization of the weight values in the deep learning is obviously important to influence the overall performance. So in this present technique which we are working, we had used Xavier initialization, but the initial way, like, there are many initialization techniques being used to initialize the initial weights. So for this particular technique, we had used Xavier initialization. And what is Xavier initialization? It is the square of the input value and the input value of the random number value of the output value. So after applying this, after applying Xavier initialization, we initialize the weights initially. Then convolutional 1 uses the Xavier initialization. Then it goes through the pooling layer, which has been described above, and then passed to the convolutional 2 layer. The convolutional two layer, as we can see, uh, yeah. So as we can see in the convolutional two layer, we are sending 126 cross 126 neuron values. They are passed through a 5 cross 5 kernel. Okay, or we can pass it through a size. Just a second. Okay, so this was convolution one there. Then we have applied rectified linear unit. So at every convolutional layer, we use an activation function called rectifier linear unit. It changes the output value of any function, like suppose f of x, to max of 0 comma x. After applying the rectifier unit, we are applying the maximum and the the LRN, which we had discussed earlier. Then the result is passed to the convolutional two layer. In the convolutional two layer, again, the same steps are repeated. So at every step, all the important features are being learned, and hence we can see the size of the image, the size of the neurons which are being passed, they are being decreasing. This was 256 cross 256 here, then we received 126 cross 126, then 63 cross 63, and finally we have reached to 32 cross 32. So after, like, what is the use of this local response normalization, which we are using after max pooling? So after the maximum pooling layer, the brightness is standardized through a layer known as LRN, which is being used at the end of every convolutional layer. So this is just used to standardize the brightness. And in this model, like, we had used a depth radius of 4. So after every, like, we have you after applying all the convolutional layers, we have reached to the fully connected layer. So after the fully connected layer, we would finally get the result as a result of the softmax function. So in the fully connected layer, in our study, two fully connected layers are used. Every layer has 4096 neurons with a standard deviation of 0.4. So this layer has the most basic deep neural network structure. We have also applied a dropout of 0.5 to each layer to solve the overfitting problem. Okay, so we have two fully connected dropout layers. In every of the dropout layers, we have 4096 features. And in the 4096 features, we have applied a dropout of 0.5 to each layer to solve the problem of overfitting. So only 2048 of each of the 4096 neutrons will be used for learning. At the end, we use a softmax layer. Okay, we use a softmax layer. That is the last layer for discrimination, and it classifies the problem based on the original data set which we had. Based on that, the labeling, we get the classification that whether the image is original or tampered. So for this particular environmental setup, like what we are working, although I don't like, presently it is not present of this system. So what we, and also it is still going on, this research is still not completed. So we are using Google TensorFlow as a deep learning framework, and the GPU of NVIDIA is used, and the image batch size is set to 100. So the images are 10,000 images. That also, that, like, we are, for now, we had used the existed GAMSIA database, but we are creating a database of our own. So that is, we have 10,000 images of 5 and 2 cross 5 and 2. So first 4,000, like, a part of the image, like around, out of those 10,000, the 8,000 images of size 5 and 2 are created by dividing the, like, we have created a set of images. We have divided the images into two horizontal and vertical divided images. And then we have tampered some images using different attacks like median filtering, Gaussian, like we have blurred the images, we have applied some noises, we have added some objects to those images. Some images have been resized, and a different noises have been added to those image. And out of, like, of these, all the images, 80% are used as learning data and 20% are used as test images. So and then, like, we are still working on, although I had worked on a lesser data set, so we were getting the accuracy of about like 89% for now. So when, like, if the value of epochs is around 15,000, we get it around 91. But as we increase the value of epochs, so we are getting the accuracy about 95 for, like, as we are increasing the database. So, but still we are trying to enhance the accuracy of the model. So maybe like some more modifications are being utilized in how to extract the features, because one target is, like, here we used high pass filter. So we can use any other filters. So the main idea lies behind, like, we can train the convolutional model, the better we are training it with the features. So we are just trying to modify how to extract the important features from the image which we are using for the convolutional layers. So maybe on the basis of those features, we would be able to improve the accuracy of this CNN model. So these are some of the references which I had, which we are using to implement it. And this is also, like, this was just a last extra image, which was an image of the modified, like, the background of the image has been just modified. So this is again an example of alpha metin or image splicing. So now if you have any queries, like, you can just text it and I would be able to answer them.
Great presentation, Sonal. So I suggest that audience put questions, and while you are putting the questions, I would like to know some data as well about the audience. With some of the people I am able to recognize, we have some people from Japan, some Italy, India, Amsterdam. Quite a good mix of audience here today. So
Okay.
I would like to know. Uh, I'm distributing a poll. If you can respond to this while some of you put in the questions.
Mhm.
So you are a software professional or a non-tech professional? So we have about some more people to go. Please respond. Another 10 seconds. Some people are still left. Please
Okay.
respond. So about it, about 90% of you are software professionals and 10% non-tech professionals. Thank you.
Okay.
Since we are talking about AI here, it's all data for us.
Okay.
What's your experience range? So we have had people like audience from age group of 17 to 65 till date. So trying to understand what's your experience level here.
Okay.
So we have about 18, about 20% of you from 0 to 3 years, 10% from 3 to 5 years, about 25% from 5 to 10 years, about 30% between 10 to 20 years, and rest of you more than 20 years.
Okay.
Great, thank you. And last one is, do you have experience in data science or computer vision? Okay, so about 45% yes, about 40% yes, and 60% no.
Okay.
Okay, thank you. So now coming to questions. Okay. What model of NVIDIA GPUs you use, and how long does it take to roughly train the batch of 10,000 images?
Okay. So for NVIDIA, like we had used for NVIDIA GeForce 1080 Ti, and
Mhm.
currently I can't because we are still working on a set of 10,000 images, like because I had just tested this is still into process. So I had tested it for a very small set of images, like for just for around 500, 700. So it was done quite quickly. But for 10,000 images, we are still preparing the database. So I won't be able to comment on the time usually it takes. So, but the
Okay.
GPU which we are using is like which we have used, which we have in our university. It's for NVIDIA GeForce 1080 Ti.
I didn't get it, the last part. Can you please repeat?
I said that the GPU of NVIDIA, the like which we have at there's just one system in a university in which we have the GPU. So we are using the GPU of NVIDIA GE Force 1080 Ti. This is what
Okay.
you talking about.
Okay. Next is, what is high pass filter?
Okay. So high pass filter is that see some parts of the image, like as we know, the image consists of various pixels. So some parts of the image are like if we modify some pixels, it is visible to the human eyes, while some parts are not visible to the human eyes. So in our case, the research which we are talking about, we are targeting on those areas which are not visible to human eyes. That means if we tamper certain areas of an image and it can be detected by the human eyes, so obviously we won't need any model or we don't need any algorithm for that. So such there are some areas where we made the changes and those changes are not visible to human eyes. So we need to target particularly on those areas in this technique. So just to extract those frequencies or those values from the image, we apply the high pass filter. So high pass filter, you can say it's a sort of filter that passes a signal with a frequency higher than a certain cutoff. So we fix like I have a matrix, like I would show a matrix to you. So we multiply the original image with that matrix, and the values which we receive above a certain value, above a certain threshold value, we only consider those pixel values and we just ignore the rest of the one. So the rest of the ones are like the only the high pass frequencies, the frequencies which won't be visible to our human eyes. Only we need to extract those from the image. So we need to extract it using the high pass filter. Maybe I would show you one if I am able to, an example of high pass filter. Just a second. Mm-mm. So just a second. There was one more example. So, like there's this is one existing paper on which we are, yeah. Suppose this is, suppose like this is usually a mathematical model of high pass filter. So this is like a lot of derivation exists behind the high pass filter. So when we apply this, when we multiply our original image with this particular value, and then we set a threshold value, only the values which lie above the threshold value are selected and the rest are ignored. So this is usually the mathematical model behind the high pass filters, and it is basically used to extract the values which are required for our research, the values from the image which are required for testing, and we can ignore the parts which are not required. So the matrix is designed accordingly. Am I clear?
Question is what was the learning parameter?
Mm, what was the learning parameter? Um, like I didn't get it. Like to the original,
Okay.
to the
So
the pixel, the weights were initialized, and on the basis of those pixel values and the features, the learning model was trained.
okay. Can GANs manipulate images be recognized?
Can manipulated images.
Right.
Uh, this I would have to test it. I'm not sure about for this particular model, but yeah, there exist some techniques like which can detect it, but not sure about this particular model.
Okay. What does LRN layer do here?
Sorry, which layer?
LRN.
Okay, the LRN layer. Just a minute. Okay. So what is the use of LRN layer? That is the local response normalization. This is like after the maximum pooling layer, we are using just to uh, standardize the brightness of the image. That is, if we have a certain values, we want to standardize those values. That is, we want to get all those values within one range. So we are for normalizing those values or for the standard normalization, we are applying the LRN. That is the local response normalization to bring them within one range.
Okay. And how many layers you have used to train the model?
So, like presently, we have just tried for 2 layers, but maybe we would be increasing it. But still now we have just kept it to 2.
Okay. Next is what about deepfake? Will image manipulation detection CNN model be able to spot deepfake videos as well?
Uh, like again, like there are like the accuracy is not that high. There are existing some techniques. I had just read some research techniques related to it, but the accuracy is not that high of detecting it. But the research is still being what like the research is still going on that particular area. But the accuracy is not that much, which is required.
Next is which tool are you using for labeling the images?
For like labeling as manual, like the
So you're saying you're doing labeling of images manually?
yeah the we have tampered the images also using like we had created an algorithm, we had created a script to tamper the images, and within the same script we are using like that's a Python script itself, and using that script we are labeling them as tampered or original, because the tampered images
Okay.
also we are creating the data set. There are some people working on it, so the data set also we are creating on our own data set, and then we are labeling it. So it's just a CSV file.
Okay. Uh, is LRN same as batch normalization?
Batch normalization,
Yeah, is LRN same as batch normalization?
uh, it is just a variation of it. Yeah, but it is similar to the batch normalization. So batch normalization is
Okay.
mainly used for improving the speed, performance, and stability of ANNs. So the LRNs is a variation of it, but yeah, it is similar to it. The functionalities.
Okay. Okay. Any other questions, audience? So we still have about 6 to 7 minutes to go. If you have any other questions, you are most welcome to ask. Go ahead. Somebody is raising hand. I would say, please ask the question. how long does it take to train the model? I think she has already responded to that before. Can you give the shortest possible explanation to image manipulation detection topic?
Okay, so just this as a summary, it would be that we know many images are being tampered. Uh, the tampering can be anything: copy pasting, resizing, replacing the faces like face detection, or changing the background, changing the foreground. Though it can be, there are many techniques available within the Photoshop to manipulate the images. And to work with them, we have two types of techniques, that is active and passive. The difference is just that in the active one, we are the owner of the images. We know which images have to be protected. We protect using some watermark or some digital signatures. So within those, there are many techniques existing. Either we want to embed the watermark by modifying the pixels, or we want to embed the watermark without modifying the pixels. And then in the case of passive approach, we do not have any particular set of images which we need to protect. It's just all the images which are being shared or available on the internet. We just need to detect whether they are modified or they are original. So the presently a lot of research is going on this particular model. And recently, like in past few years, the deep neural networks, the CNNs, have come into picture, because like many features, like a lot of research has been going on, like which all features are important to train the models, how we can improve the accuracy. As such, no too much accurate model exists, but a lot of work is being going on this part, that is the passive approach, in which, and presently, in fact presently on the CNNs, to how to train the models. In this, we just need to input any image and need to detect whether that image is tampered or original. So the main idea lies about how to train that model and how to improve the accuracy of that training model. And that would be improved by either the feature extraction or the learning features which we are providing, or all the layers and how we can modify the within layers. So the present area of research is the passive approach. So out of that,
Okay.
I had introduced a small introduction to like to the active, and for the passive, a brief intro of the CNN.
Okay. One question from my side, Sonal. Uh, Question is that a lot of small social media agencies or content making agencies don't have budgets to the buy images from image sites. So they take up any image from Google Images and slightly modify it or use them. So
Right.
is there any tool in the market which can tell them that this is watermarked or anything like that? Because if they use it and with the what is that with European regulations coming in, there's huge problem for digital agencies to be using watermarked images in
So
from anywhere on
actually,
internet.
like for those images, like I was um, like few months back also, I was just searching for all apps or websites which provide such service. So I think within like I had one, there is one tool of the Shutterstock images also. Like they have one additional
Mhm.
tool which I had just taught to their customer care how does their work. Like I taught to their developing team. So they are some, like not very proficient, but at least for digital watermarking, like whether if the image is already marked, and then to detect whether the right owner is claiming it or not. So some tools and apps exist for such techniques, but just for the generalized, that is for the active approach, just for the generalized images, just to detect whether the image is original or tampered, still as such not a very proficient tool exists, but a lot of models exist which can be, convert like which can be market, which can be brought into market. Like the research, this is a current research which is going on the active approach, But for the passive one, a lot of model exist, out of which I just have knowledge about the Shutterstock tool. I don't remember the name of that tool, but I had talked to their development team, so they have one tool with them. So if you provide any image to them, so they can detect whether that image is original or modified.
Okay, thank you. Next question is, will we use any in healthcare images for risk prediction? Uh,
I didn't get
can
it.
you please elaborate the question? I did not understand the question completely. Statement says, will we use in healthcare images for risk prediction? I'm not sure about the
See, the
completeness of the. Yeah.
if you are talking about just the medical images and like the medical images, that is a complete different research area. There, like, I had recently met some people who are working on medical images, but like it's quite different from the social media images. And in the medical images, we have a very different set of features which we need to study about. That that's a complete different domain. So when although there is some research models existing based on CNN and deep learning for those medical images also, but that is a complete different models, because the features which we need to learn, because they are very what we can say, like even if a small modification may result into a very different result. So that is a complete different model which cannot be mixed with this particular one.
Right. I'm just going through if I have left any questions in between. Otherwise, no more are coming here. So I think we are good. No more questions coming in.
Okay.
So audience, just one last minute if you want to ask any questions. Otherwise, we'll end the webinar. So thank you all for attending and participating in the polls, and thank you, Sonal, for a very good presentation. We hope to have you again for some more topics. Your research topic is very good and deep. Look forward to more webinars and seminars from you in near future. Thank you and have a nice day.
Thank you. Thank you all.